Good morning, guys. I'm going to include in this video a brief revision about linear equation. As first, linear equation. First, we are going to refer to the structure of a linear equation. We are going to recognize this kind of expression, mx plus b, okay, where we can see the degree of the expression is 1. That means all the linear equations has degree 1, okay. In this in the linear equation we can recognize this formula, that is the standard form, okay, and where we can recognize a second form, that is the ax plus bx equal plus by equal c. It is the gradient intercept form, okay. As an example of this, for example, if we have an expression like y equal 2x plus 4, it is in a standard form. But in case we need to convert this into a gradient intercept form, we need to apply inverse opposite operation. That means writing again the expression, we need to have ax, that means the value of x needs to be on the left side. That is, in this case, opposite operation means it is plus, now it's minus, that is minus 2x. I'm going to plus y equal 4, and then it is the gradient intercept 4, okay, gradient intercept 4. If you analyze, this expression is similar to this expression because we have the component c on the right, we have the y, that is by, and a minus 2x, that is ax, okay. Now for this kind of equations we can find a graph, okay. We can graph a linear equation. How to graph a linear equation? For example, we're going to create a table. And for example, like we have this expression 2x plus 4, okay. Remember, to graph a linear equation, you need to get the equation in the standard form, okay, in a standard form. In this case, we're going to create values for x. In this case, I'm going to say that values for x can be always 1, 2, 3, 0, minus 1, minus 2. Try to include negative and positive values. Now, by doing the expression, for example, y equal to x plus 4, we're going to replace every time the values for x depending the values you have in the table. For example, y equal to, taking the first value, that is 1 plus 4. 2 times 1 is 2 plus 4 is 6. Therefore, the value for y when x is 1 is 6. Now, for example, doing it with 2, y equal 2 times 2. Remember, when you don't have a you have a variable and a number, you are multiplying, plus 4. Y equal 2 times 2 is 4 plus 4. And the y is equal 8. And on this way, doing it every time, okay. 2 times 3, 6, that is 10, 12, 12, sorry, no 12 because it's 0. When it's 0, the value is this value of here, okay. Minus 1, 2 times minus 1 is minus 2, plus 2 plus 4 is 2, and in this one is 0, okay. Now when you get the table, we can graph. Now we are gonna graph. I'm going to make a space because it's easy having the table, and then we can refer to the graph. Okay, for example, we have this is x, this is y. Okay, now by graphing the points, taking into account the different coordinates we will have, that is 1 2 3 4 5, -1 -2 -3 for x, and in here is 1 2 3 4. Okay, now plotting the points, that is 1 and 6. 1 and 6 is over here, is an example. We will have 2 8. 2 8 is gonna be over here. 2 8. 2 8. Wait a minute. 2 8. 3 10. Okay. 0 4. -1 is 2, and -2 is 0. Okay. Okay. If we can see, we can join the points. Sorry for this line, but this is the idea. Okay. And if you see, we have a linear tendency. That is the way we can graph. Okay. Now we can also make a linear equation by having the different points that come for the linear equation. First, we need to recognize something about this structure. For example, the M is called slope or gradient, and the B is called y-intercept. Okay, intercept. Okay, y-intercept. I'll write this in a different place just to make it intercept. Okay, now for example, if we have the following: gradient of -2 and y-intercept of 4. In that sense, as you see, we already have the parts of a linear equation. Constantly, we are gonna write always y equal x. That means in this kind of a structure, we only need to add the slope and the y-intercept. As you have in this problem, what is the slope? The slope or the gradient is -2, and the y-intercept is 4. When it's only 4, it's +4. In other cases, you will have the negative symbol. Okay. Now, finally, some characteristics of linear equations. Linear equation features. Okay. For example, I'm going to say the following. We will have this, and we will have those coordinate planes, and those coordinate planes, for example, I will have two lines, this line and this line. Okay, and I will have this line and this line. Okay, if you see those lines, they are parallel lines, and this representation is perpendicular lines. Perpendicular lines. Okay, why? Because we are getting a degree of 90 degrees in the vertex of the lines. Okay, why it is important with linear equations? Because, for example, when you have parallel lines, as you see, they are parallel, they have the same slope the same slope, but different y-intercept. While in perpendicular, for example, we have a inverse slopes and different y-intercept. I'm going to do an example right now. Y-intercept. For example, we are going to suppose for those representations the equation, for example, for this line is going to be y equal to x plus 4. Okay. Now we need to find the equation for the second line. The equation of the second line is going to be y equal to x because it needs to be the same slope but different y-intercept. Which y-intercept? Depending over which place is crossing the line. I can say -8, okay? And that is the way we can find, based on parallel lines, a linear equation. Now, in perpendicular, it's going to be a little hard because, for example, I'm going to say for this line, I'm going to say that y is equal to, it's an example, okay? Because if you see, it is a straight line. 2x plus 4. Okay? But we need to find the equation of this line. Yeah? What is the equation of this line? Therefore, we will have that the slopes are opposite. Therefore, y equal, what is the slope for this line is 2x. The opposite of 2x is writing over 1 below the 2 and writing the 1 now at the top and the 2 at the bottom, 1/2 x plus the, depending where is the line is crossing, I'm going to say this 5, okay? Okay, that is the way we can identify different equations based on if we have parallel lines or perpendicular lines, okay? Finally, for this, we will have how to find the slope. The slope, we know, is the value for m in the linear equation. How to find the slope? The slope is, we can find the slope by applying the following expression. y2 minus y1 over x2 minus x1. How to apply this formula? The formula is applied when you have two coordinates. You need two coordinates to apply this formula. For example, I will have, for example, -1, 3 and 2, 5. To find the slope or the gradient of this, we are gonna replace the values. My recommendation is, for example, the first value of a coordinate is x and the second is y. The first one is x and the second is y. In the same order, I'm going to point out this is x1, y2, x2, y2. And then replacing the formula. That means m equal, y2 is equal to 3, is this one, minus from the formula, this minus, y2, y1, it is y1. Sorry, I made a mistake here. It is 1. Yeah. Therefore, y2 is equal to 5, is this one. Y1 is this one, minus 3, over x2 is 2, minus from the formula, and now it is minus from the number, -1. Therefore, the slope is equal to 5 minus 3 is 2, over minus and minus, we can combine the symbol is plus, is 2 plus 1 is 3. And that is the way we can find the slope based on two coordinates, okay? Taking into consideration, as I said before, that one thing is the symbol, is the negative symbol from the formula and the negative symbol from the number, okay? Okay, guys, with this brief revision of linear equation, you will have enough to complete any worksheet you have about this topic. Have a nice day.